Hello. Today we'll discuss about diffraction by double slit. In the last few classes we are discussing about superposition of light waves. The first we have discussed about interference. Then in the last section we are discussing about diffraction by single slit. So when you talk about diffraction by double slit, it's basically a combination of interference pattern and the diffraction by single slit. So to discuss this thing, we're going to take a simple experimental setup when you have source of light and you have a slit, two slits basically. So when primary light waves are coming, they will be exposed in these two slits. And remember this, in this case the slit width also, say slit width can be considered as d. This is comparable to wavelength of light. Okay, so this was the condition for diffraction, what we have discussed in the last. So here we have two slits having equal, almost a similar slit width of d, and they must be comparable to the wavelength of the incident. Now those fluctuations are there, the secondary light waves are there, so they will produce two different waves. So this picture is shown over there. So this is S1 and S2. So consider this is S1 and S2. So they are acting as a source of light. The source of light will be considered as a secondary light. They will superpose with each other. So electric fields are fluctuating from source 1 and source 2. They will interact with each other and will produce diffraction pattern. And this will be the case of double slit diffraction. So how do it look like? The diffraction pattern looks something like this. So you have a distinct dissimilarities between single slit diffraction and double slit diffraction. So in case of single slit diffraction, you will get a brighter central region, central maxima. Then we have the secondary maximas. But if you are watching it properly, you can see in the central maxima and in the secondary maximas region, there are some of the dark sections. This is explained by a overlapping of diffraction pattern and along with the interference. So when you have two slits, so individual slits acting as a source of light, secondary source. So they are producing diffraction patterns. Okay? And as a whole, so S1 and S2, as they have a constant phase difference between them, so they will act as a source of coherent light sources, which help to produce the interference. So there will be overlapping of diffraction pattern along with the effect of interference. So to continue this discussion, so let me just check what we have discussed in our earlier section about interference and diffraction by single slit. So come here. Now in case of interference, just check it. So in case of interference, the condition of interference must be the wave must be coherent in nature. So when they are coherent, so they will superpose with each other. So two waves we are considering. So they are having some phase. The phase value must be 0 or constant. So when they are constants, you will get a resultant wave equation, something like this. So the time dependent part in this resultant wave equation is known as the amplitude. Now amplitude is a function of phi. Now, when cos phi is equal to 0, this will give you the condition for minima. So, overall amplitude part becomes minima. And it will happen when the phi by 2 values are 2p plus 1 into pi by 2. Where p value varies from 0 plus minus 1 to all the integer values. Same way, if the cos phi by 2 is equal to 1, so this will give you the maximum value of 2 into a, and squaring this one, this will give you the intensity of this. So it will be observed when this becomes p pi, okay, or 2p pi by 2, where p is again some integer. So these are the conditions for minima and maxima for the case of interference. Now for interference, you need coherent light sources. And you will be able to get, if you are able to satisfy these conditions, so you will get the conditions for maxima and minima. So this is the pattern for maxima and minima in case of interference. Now come to the case of diffraction. So in case of diffraction, the formation of secondary light sources are very, very important. They will superpose and will produce diffraction pattern, something like this. So in case of diffraction pattern, the central region will be very bright, and then you have the secondary maxima along with the minimas. So when you are considering a single slit diffraction, you have considered n number of secondary light sources are there and they are superposing with each other, and when they are superposing, this is the resultant wave equation. But the resultant amplitude is given by this in simplified form. The resultant amplitude is given by this particular expression. Now, in case of double slit diffraction, we need to consider that there are two secondary light sources, source of secondary light waves, and they are basically diffracted wave from S1 and also from S2. So the wave equation coming from S1 can be represented at, say, I am representing it by Y1. Okay, so this is A is the amplitude. Again, this can be considered as sin omega t. Remember, this A is not a constant like our ordinary amplitude. Now, this can be considered as n into A sin beta divided by. Now, what is NA? N is the number of secondary light sources. You can consider number of secondary light sources are there, and A, it denotes the individual secondary waves amplitude. Individual waves amplitude. Multiplied with sin beta by beta, but beta is given as pi d sin theta divided by lambda. So, beta is function of theta. And what is theta? Theta is the angle between undeviated ray and deviated ray. So, this angle will be considered as theta. Okay, this may be theta 1, theta 2, theta 3 accordingly depending on the diffraction pattern order. Now, if you are considering the second wave, say this is Y2. Y2 can be considered as A. Again, I am considering A similar amplitude sin omega t plus phi. Okay. So, you have almost a similar equation like interference. So, obviously, when you are superposing with each other, when we need to add this one, so sin y1 plus y2. So, it simply gives a 2 into sin C plus sin D formula we can use here. 2 into A multiplied with, so you can consider sin C plus D by 2. So, this will be 2 omega t plus omega 2 omega t plus phi by 2. So, this will be 2 omega t plus phi by 2. So, you have a time dependent. And then multiplied with cos. The cos will be omega t minus phi by 2. So, omega t will be adjusted with each other. So, this will be left with minus phi by 2. And minus of theta means minus of cos minus of theta is equal to cos plus theta. Now, one can easily check this in that 2 into A and cos phi by 2, this is time independent part, whereas sin omega t plus phi by 2, this is the time dependent part. So, one can consider this is as the resultant amplitude part. Say I am representing it by R. So, R is given as cos 2 into A cos phi. Okay. Now, remember what is A? A is given by n into A sin beta by beta. So, let me just rewrite it here. N into A sin beta by beta into cos. This is the resultant amplitude term of double slit diffraction pattern. So, when you have resultant amplitude, squaring this one, this will give you the intensity. So, this becomes square of this one. Okay, actually, this is squaring of all of this stuff. Squaring of all of this stuff. So, when you are squaring this one, one can get 4 n into A whole square. N into A whole square can be represented as I0 intensity, the central maxima intensity. Then comes the case sin square beta. divided by beta square into cos square phi by 2. Now one can easily see in this expression, in this intensity expression, there are two terms. The first term is sine square beta by beta square. This is the case of single slit diffraction. And the second one, this is given as cos square phi by 2. This is the case of interference. So we have an overlapping of interference pattern and diffraction pattern. So let me just check the derivation part. You have this expression y1, y2, and you have finally you have 2a cos phi by 2. I am representing it by gamma. We have a similarity with respect to beta. So the intensity term 4I0, actually this is 4I0, this will not be square, 4I0, this is n into a whole square, so this is I0, 4I0 sine square beta by beta square into cos square gamma. So where gamma is denoted as, this is phi by 2. Now let me just talk about beta. Beta is pi d sine theta divided by lambda. So just remember it, here we are talking about interference. So what is interference? We have two light sources, and if they are coherent in nature, so they will produce the interference term. So how will get a coherence term? So to explain coherent terms, we need to consider two sources, and they must be in zero or at constant phase difference. Okay, so one can easily consider the diffraction pattern are basically coming from these two individual light sources. So a double slit can be considered as individual single slits, and as a whole, these two slits as a whole, they are acting as a source of interference. So when you are talking about a single source of light, so you can consider one ray, undeviated ray and deviated ray. So this is the angle in between. So what is the path difference? You can easily calculate. You can consider two lights, say y1 and y2, two secondary light sources, and one can consider the path difference between this. So one can draw a normal over there, and you will form the triangle with this. This side is known, this side is d, this angle is theta. So the path difference between this will be given as d sine theta. Now you have two light sources. Okay, you have two light sources, and this is the undeviated ray, and you can get the deviated ray. Again, to get the path difference, we need to draw a normal over there. Now this distance is given by d plus b if the gap between the two slits is b. So one can consider a triangle here. This is given as b plus d, and this side this angle is theta. So obviously this particular additional path difference is known as b plus d. So this is given by this expression gamma. So pi b plus d sine theta divided by. So how we are getting this b beta pi d sine theta by lambda? This was explained in the single slit discussion. You can refer this to. Now the most important part, the factor sine square beta by beta square, it comes due to the diffraction from the individual slit, individual single slits. And the cos square gamma part, actually cos square phi by 2 terms, it comes due to interference from two different sources. Okay, so two different sources, they are acting as a source of coherent light sources, and individual sources, they are acting as a source of diffraction light sources. So obviously they will overlap with each other. Now when you have this thing, you need to consider the condition for maxima and minima. So there is a condition for central maxima. So again, central maxima will be depending on this particular relation. When sine beta by beta, this is equal to 1, and when this will happen, when sine beta tends to 0 and beta is function of theta. Actually theta, when theta tends to 0, one can get the condition of central maxima. And there are two cases of diffraction and interference. So separately we have considered the cases. So case number 1, first we have considered the minima for diffraction and also for interference. So sine beta, when sine beta is equal to 0, we have the case of diffraction minima. And when sin beta is 0, so beta values are plus minus 2m pi by 2. Plus minus 2m pi by 2 or m pi 1. Where m is some integer value, plus minus 1, 2. So if you simplify this one, if you put the value of beta pi d sin theta divided by lambda and this side 2m pi by 2. So you can just rearrange this one and you will come out to this expression d sin theta equal to m. Okay. So we can get the angular width between two consecutive minimas. Okay. So m1 and m2. So you can get what are the sign values. Now the case of interference. Cos square. This is equal to 0. When this is possible? When 2p plus minus 1 pi by 2. But again, p is some integer. And gamma value is given as pi b plus d sin theta divided by lambda. The two coherent light sources. Rearrange this one. This will give you b plus d sin theta plus minus 2p plus 1 lambda by 2. Again, just reverse the case for maxima. First one, diffraction maxima. Again, this is when beta is equal to 2m plus minus 1 pi by 2. And interference minima when cos value becomes 1. Okay. So just you can see what is the condition for diffraction minima. This is the condition for interference maxima. This value. Okay. And when you are comparing interference minima, this is equal to this type of conditions. This is equal to diffraction maxima. So these are the conditions for minima and maxima. Now the pattern, how it is look like. Now see, you have an effect of sine square beta by beta square. So here you have a central maxima, you have a bright zone, then you have the secondary maximas along with minima. And what is interference? Interference intensities are uniformly distributed. All the maximas are of uniform intensities and you have the minima. So bright and dark points are there. So they will overlap with each other. So one can get a diffraction pattern in case of double slit is overlapping of diffraction pattern with interference. So here you can see when they are overlapping with each other, which was supposed to be a bright point, you will get some of the dark points over. Now, this is the picture. This is the real experimental picture what we have shown. This is the single slit diffraction. So, in case of single slit diffraction, one can get a bright zone. Then you have the dark one. This is the central maxima or primary maxima. Then you have dark point and then the secondary maximas are appearing. But in case of double slit diffraction, the central region, the secondary, the primary maxima or central maxima is overlapped with interference maximas and minimas. You can see bright points along with some of the dark points are there because of this particular point. This point, these are denoting the dark. So this is the basic difference between single slit diffraction and double slit diffraction. Now when they are overlapping, an important type of phenomenon was observed on the screen, which is known as the missing order. So missing order is the case when interference maxima is overlapping with the diffraction minima. Remember it, interference maxima is a very bright point. And diffraction minima is not exactly dark. You have some very less intensity, but it's not exactly dark. So when this will overlap with each other, obviously the dark point will be missing. This is known as missing order in case of double slit experiment. Now, we have already discussed about the conditions for interference maxima and diffraction minima. So we have just considered this thing. Just refer this one. I'm just considering. So interference maxima. This is b plus d sin theta. Okay, b plus d sin theta into p lambda 2 can be done. And diffraction minima. What is diffraction minima? Diffraction minima is given as d sin theta equal to m. What we are doing, just rewrite this particular part. This should be P. So what we are just showing that P is of any order. So this may be 1, 2, 3 or 4. Or M may be of any order, maybe 2, 3 or 4. It may be equal, may not be equal. But what is our condition? When they are overlapping. When they are overlapping, so these values are equal. So angles are equal. Okay. So one can think about two light sources over there and a screen over there. So you can just think about a point somewhere here. Okay. So at that particular point, you have interference maxima and also diffraction minima there. They are overlapping with each other. So maxima is overlapping with minima. So everything is maxima. No minima is present over here. So this is the case of missing. Now when these values are equal, so obviously the sign values are equal. Now equation number 1 and equation number 2. Okay. So if you are dividing this one, so sign, these values are equal, they will be balanced with each other. So what is left? B plus D divided by D. This is equal to P by M. And obviously you are using a single light source, so the lambda values will also be equal. Now the case is if B is equal to D. So if B is equal to D, so you will get 2D divided by D. So one can write P by M, this is equal to 2. What is the meaning of this thing? Meaning is second diffraction minima. Second diffraction minima will be overlapped by interference maxima. One can check some other conditions also. What are the conditions? Here I have taken, this becomes twice D is equal to B. So if this is twice of D, this is equal to B. So obviously this will become 3D by D. So D will be balanced with each other. P by M is equal to 3. So P is equal to 3. Again, the conclusion is third diffraction minima will be overlapped by interference. So if you arrange the distance between the slits, then you can arrange the diffraction pattern on the screen. And you will be sure about this one, which order will be missing, which order will be overlapped by interference pattern. So this is the idea about diffraction by single slit. A simple recapitulation. So in case of double slit diffraction, this is the case of double slit. With the double slit diffraction, you have two light sources. So two individual light sources will act as secondary light sources, superpose secondary light sources. This will produce diffraction pattern. But two light sources having constant path difference, so constant phase difference will be there. So individual sources, or as a combination of two sources, this will act as a coherent light sources and they will produce interference. So on the screen one can get a effect of diffraction and interference. So the intensity distribution is given by 4I0, where I0 is equal to n into a whole square. N is the number of secondary light sources and a is the individual waves amplitude, individual secondary waves amplitude. Then it becomes sin square beta by beta square and cos square gamma. So sin square beta by beta square is appearing due to the diffraction and cos square gamma is appearing due to interference. Then from that we are able to get what are the conditions. Condition for diffraction minima, interference minima, diffraction maxima and interference maxima. So these are basically reverse in order. So diffraction minima, and they have a similar mathematical relation for interference maxima. And it is also happening for interference minima and diffraction maxima. Now the diffraction pattern was explained. The diffraction maximas are overlapped by interference maxima and also interference minima. So pattern looks something like this. Now again we have considered a special case of missing order. So in this missing order, interference maxima is overlapped by interference maxima is overlapped over diffraction minima. Okay, so this minima is overlapped, so minima will be missing. So overall maxima will be observed